A decade is over, but still ReactJS is one of the most prominent library for developing web and mobile application. Hey, this is Tapas. I'm an educator having 15 plus years of experience developing software and mainly in the side of web development, engineering and architecting web application. So in this series, I'm going to discuss with you varieties of interview questions that you may face when you go for web development or mobile development interviews where ReactJS is the primary center of attraction. Okay, without any further delay, let us get started with the interview questions. I hope you enjoy them. If you have any comments, if you have further questions, feel free to post your comment, post your questions, and we'll try our best to kind of get back to you. All right, without any further delay, let's get started. In ReactJS Interview Questions series, we are going to take you through multiple ReactJS aspects and discuss about some of the tricky questions that you may face in your interviews, right? So this entire series is broken into 5 parts. In part 1, which is in this video, we are going to cover questions from ReactJS foundational topic, from JSX, from components, from states and the props. So if you're already aware of some of these concepts, great, it will be really good for you to kind of follow the questions that we'll be discussing. In case you are new to it, the suggestion would be is like when we are discussing a question, and if you find that you have to read a little bit more about this from a tutorial or from any other video, please feel free to do so and then come back to this question and answer to get a better grip on it. Okay, so let's talk about what are those 5 parts. So in this entire series, the first one today is about the foundations, JSX, components, state and props, as we told. In the part 2, we'll be discussing about form handling. We'll be discussing about events, virtual DOM. So the questions will be from those area. In the part 3, we'll be talking about React hooks, context APIs, Redux. In part 4, we'll be talking about styling, error boundaries, code splitting, performance related questions. And the final part, we'll be talking about patterns, we'll be talking about debugging a ReactJS application, we'll be talking about tools. So there are a lot of exciting things that are there in store for us to discuss. Let's get started with our part 1 and the first question of the day. The first question is about how is ReactJS declarative and how does it help? So we keep hearing or keep listening to this thing like ReactJS is declarative. What exactly declarative means and how exactly it helps in real life or in the application development? Now, while we answer this question, we have to understand few aspects. The first aspect is called what is the difference between declarative versus imperative. Then we'll understand why ReactJS is declarative and what are the advantages. Why ReactJS is declarative and what are the advantages, we'll learn it through code examples. But first, let us find out what is the difference between declarative and imperative programming. So in declarative programming, what happened basically, you describe the programming language, you tell that programming language, hey programming language, this is what I want you to do, but you not necessarily specify how it should be done. That is declarative. In case of imperative programming, what happened, you describe, hey programming language, this is what I want, but along with that you also tell the programming language how you want it to be done. You provide the instructions as well. So this is the biggest difference. Like in declarative, you just say what to be done and it is done for you. You don't get into the underlying details, you don't get into the underlying facts. But in case of imperative, you tell what needs to be done and you also say how it needs to be done. So with these two fundamental differences, now let us see some code and try to figure it out. What is imperative, what is declarative, and how React is declarative. First, let us see some imperative coding. Okay, so here we have a HTML file, index.html file, a simple file which is having body, one h1 tag, one p tag, one UL with an ID, and there is a script that we are actually calling here. It's called index.js. Now, if I go to index.js, what it has an array of strings, some simple strings. And then there is a function. That function is doing something. Okay, we'll get into that. And then we are calling this function. So it means wherever this index.html file is rendered on the browser, all this structure will be created and this particular script file will be called, and once the script file gets called, this function will be called, and every code inside this function will be executed. Okay, so this is as simple as that. Now what is there inside this particular function? What is the code? That let us see. So first thing it does is basically it gets an element by its ID called yReact. So if I go to index.html, I have a UL with an ID called yReact. So nothing but it is getting this UL element in this file. So once it gets this UL element, what it is doing, it is creating few more DOM elements. It's creating a h2 tag. In the h2 tag, it is putting a text called yReact, adding a CSS, adding a class to that, and then finally adding this heading to the UL. Then it is iterating through this array of string, and each of this string value it is adding into a list element, li element, and finally the li element gets added to the ul element. So what we are doing here, we have got a structure in HTML, and here inside this ul we are adding a heading and then a bunch of list li based on this array iteration. How many elements are there in the array, that many li we are adding. Okay, now why this is an imperative programming? Why, how can we say that this is an imperative programming? The reason being, so we'll see first, this is the code output. So if I go and just open this guy over here, inspect this one, so you see you have ul yReact, and then right after that you have this h2 is called yReact with the class heading, and then you have a bunch of li. In each of the li you have each of the text from that array. That is what it is doing, a very simple thing. Now why it is imperative? It's because here you are telling the application, the programming language, hey programming language, in this case JavaScript, you give me a ul li list, you also give me a heading inside the ul element, and inside the heading you please put this particular text, and then inside each of the li you put each of this text. You are telling to do this, and while telling that, you yourself actually writing code to get this thing done. You yourself creating an element on the DOM, you yourself actually updating the DOM element, you yourself doing lot of DOM manipulation by yourself. So this is why this kind of programming is an imperative programming, where you tell what needs to be done plus you tell how it has to be done. Now the next thing that we are going to see is something called declarative programming. So for that, the same thing I have written as a React component. So this is, we'll be getting into a React component, exactly same thing, but lot of simplified code. What is happening in this case? Same array of strings. Now this array of strings is used as a state variable over here. If you know in React that every component you can create a private data called state as a state variable over here, and then here you iterate through this particular array, and then you create li element under this ul, and there is a heading h2 is already over here. Now if you notice here you are still telling that hey React, I want a h2 inside ul, and I want the li tags to be added inside this ul, but you yourself not doing any kind of DOM manipulation. You are not manipulating the DOM at all. It is React which is doing it in the background. That's why this is declarative. Now React being declarative, you have a lot of advantage because there's a lot of nuisances you might face while doing the DOM manipulation that you don't have to do at all, which you will be doing in the plain JavaScript if you have to build an application using plain JavaScript. But with React you don't have to do that. You provide the instruction, and then React is going to do this DOM manipulation and DOM update, the rendering, all these things on your behalf, right? That's why React is declarative. That's why it works very well being a declarative language. I hope this question and the answer is clear to you. Let's get started with the second question. The second question is, what is the significance of the React.StrictMode in React.js? If you are getting started with the React.js application, at the entry point file like in index.js or main.js or app.js, whatever it is, you will usually see something called React.StrictMode, one tag. So what is strict mode and how does it help? This is the topic, and this is the thing that we are going to discuss now. Many a time you find an issue in the production mode and you wish, if I had found this issue in the development mode, I could have fixed it that time itself. React.StrictMode exactly going to help you with that. in the React.strict mode, if the strict mode is on, in that case, in the development mode, you have lot of chances of catching the error early. Now to make the strict mode on, the simple thing is like just enclose your application with React.strict_mode tag. Now you can make the entire application in strict mode by doing this, or if you want to do it partially, you can do that also. So partially you can make an application in strict mode. How do you do that? Let me quickly just paste this code to explain this one. So in this case, what we are doing, basically this header we are not putting in the strict mode at all, whereas we are saying that apart from header and footer, rest of the pieces in the application can be in strict mode. So you can actually put the entire application in the strict mode, or you can put the thing partially as you want. But why and where this strict mode is going to be helpful for us? Let us try to understand that thing. So there are a few cases where you can find that strict mode will be helpful. One would be if you want to see if the bugs are in your development mode, which is related to your state management, maybe your state is not getting updated correctly, or your use effect, the side effect that you are managing, and you are not cleaning up your side effect correctly. All these cases you can actually start realizing that on the strict mode. So in the strict mode, you will see that the rendering happened twice. Okay, so once somebody asks you about the strict mode in interview, they might also ask a question like, why in strict mode the rendering happens twice? Why? Because in React it is assumed that every component you write, it should be a pure function. What exactly a pure function? A pure function means it's a React component should always return the same JSX for the same input. So it means if you pass the same input to a component, input means same props, same state or same context, for the same prop, state or context, it is going to return the same JSX output value. That is what is called the pure function or the pure component. Now React.StrictMode runs or render it twice because it just want to validate for different renders, for different kind of for the same kind of input, your component should not result out a different output. It means that your component should not be impure. The moment it finds that our component is impure, then it raises the flag and you should be able to kind of start fixing the issue, right? That's why the strict mode is very, very important. Another thing is like if you put the strict mode on like this, you are going to get a lot of warning for your deprecated APIs if usage. So if you have used any kind of deprecated API which was like there before, but now React is kind of taking those off, if still there in the code, things works, but in future React might just take them out. So that time your backward compatibility might break. So why to use those kind of API? You can stop using it, and the way that you know that the strict mode catch it and tell you like not to use it. So these are the vital usages, like why React.strict mode is very, very helpful in the debugging mode, in the development mode. When you are before going to production, you want to catch up few errors, you have to catch up things. That is when you should be using strict mode. Let's get started with the next question. The next interview question is how to handle ReactJS lifecycle methods in functional components. Now in ReactJS, you can create components in two ways. One with legacy class-based components, and another is the functional components, which most of the React developers are using today because of its several flexibilities. And one of the flexibility is about writing React hooks. Now, there are certain lifecycle methods that you must be already aware, or you will come to know when you learn React, that these lifecycle methods are something that as a developer you need to know so that you can hook into these methods and try to do certain activities. So in class-based components, there are well-defined lifecycle methods that developer used for writing lot of business logic. What are the life cycles? There are basically three major life cycles. One is called mounting, one is called updating, and another is called unmounting. So mounting, updating, and unmounting. Mounting means you are putting certain elements into DOM. Okay, that is what the mounting is. So when the mounting happens, it goes through few phases. Now the picture that we are seeing on the screen, this is probably a lightweight picture of something which is little more complex, and we don't want to get through it all because our objective is not learning the life cycle in depth, rather want to learn like how this life cycle thing can be achieved in the functional component. So we'll take an overview of life cycle methods right now. So in the life cycle, first thing is like mounting. In the mounting, the first thing that comes into picture is called constructor. So constructor is nothing but a method that is called at the beginning. Before anything else get called, is components constructor gets called. And when components constructor gets called, this is where we want to initialize things. We want to make things ready so that those things we can use down the line in the component for our use case and for our business logic. So first thing is the constructor. Once the constructor part is over, then the next thing comes as a render. The thing that you see over here is called render. What is render? Render is basically it's a method that actually output your theme on the DOM. So it means that you have initialized certain variable, certain state. Now you want to show the value of that on the DOM, right? The HTML output. That is where the render function come into the picture. After render, there are things like component did mount. That is another method that you need to know. So what happened in component did mount? Before component did mount happen, React basically updates the DOM. React basically update the refs, all these things. But when the component did mount, it means that component has loaded for the first time. The component has loaded for the first time. This is the state where we say component did mount. And if you want to do certain things and this particular lifecycle method, when this lifecycle method happened, you can actually start doing that. Then the next thing that happened is called component did update. Components did update. What is component did update? The component did update method is related to the update fact, the state update, basically where you want to update your state, right? This method is called after the component is updated in the DOM. Once the component is updated in the DOM, then the component did update method gets called. And at the end, when the component is taken out of the DOM, then component will method will be called. So this is how the methods are there, and there is a one-on-one mapping of each of this thing with your class-based component. Now, when it comes to the function-based component, how all these things happen? These methods are not used in the function-based component directly. Rather, in the function-based component, we use one thing called use effect. Use effect is a standard React hook. The standard React hook means is a hook that is given by React itself. And this one hook is nothing but you can think about a simple JavaScript function, but it has certain flexibility and additional capability of React. So why it is little bit different than standard utility JavaScript function. It is basically given by React with certain kind of flexibility functionality inbuilt with it for you to take care of few things. For example, use effect helps you to take care of side effect. Side effects means you want to make an asynchronous call, you want to log something into the file, something that is not directly related to the component output, but it actually impact the final output of your component is called side effect. Now, to manage all the side effect, you use a hook called use effect. Now, all these lifecycle methods that we have seen so far, like component did mount and render and all these things, that everything together we can actually start taking care using use effect hook. So let's see how use effect takes care of it. So we just learned that in functional components we can use the use effect hook to handle the lifecycle methods of a component, right? The use effect hook is called after the component is rendered and can be used to perform any kind of side effects such as fetching the data from the API, or you want to update the DOM, all this kind of things. I'm going to take you through this particular code, but before that, let me just call it out that use effect is a standard hook that you can import from React itself. And the use effects, if you look at the signature, what exactly it does, it takes a callback function. That is what it is over here, a callback function. Inside this, you write your effect. Basically, whatever you want to do, you want to make an asynchronous call, you want to do DOM update, everything you write inside this. Along with that, there are few specialty. is like use effect takes another additional parameter. In this case, you can pass optionally an array. What exactly this array does, if you don't pass this array at all, that means your effect will run every time. Okay, without any kind of external dependencies, your effect is going to run every time if you don't pass this empty array. If you pass this empty array, it means that without any values into it, your effect will run only once at the beginning. So if it is an empty array, it will run only at the beginning, only once. That is when your effect is going to run. And this particular phenomena is something similar to your component did mount lifecycle method. What we have learned just now, component did mount lifecycle method, that is where when the actually component mount for the first time, that's when it runs. Similarly, if you are doing use effect with an empty array without any dependencies, that's when it is going to run like component did mount. Now to replicate the functionality of component did update, which is like once the component gets updated, right, that is when you want to run. That is when you can pass the state or the props to this particular subscript array. So if you pass for example, just assume that there is another state called state, or there is a props that this particular component has called props. So it means that whenever there is a state change or whenever there is a props change, only then you run the side effect again. So the side effect running is depending on either the state or the props. This is similar to component did update that we actually learned, which is there for the class component. Now the last one, component will unmount. To replicate the functionality of component will unmount, you can return a cleanup function from the use effect. What exactly cleanup function? Any function that you return from the use effect is called a cleanup function. This is a cleanup function. So if you call this cleanup function, this is similar to what happened when we call this component will unmount. That means when component is taken out from the DOM, you want to do something. Similarly, when the component gets unmounted, you want to do some cleanup. What kind of cleanup? You might have opened a database connection, you want to close it, or an IO connection, you want to close it, or you want to remove the things from the local storage. There could be various use cases based on your thing, right? What you want to do. So this is what it is. Just to kind of reiterate all these things again. In case of to replicate the functionality of component did mount, you can pass an empty array as a second argument of use effect. That is when the component did mount. To replicate the functionality of component did update, you can pass the state or the props that you want to watch the changes to run the effect. That is when you can pass, that is a component did update. To replicate the functionality of component will unmount, you can return a cleanup function, the one that we are doing from here, from the use effect, that will be called when the component is unmounted. So that's how you take care of the lifecycle method. Hope it is clear now. Let's get started with our next question. The next question is, what are controlled and uncontrolled components in React.js? And what are their usages? So to answer to this question, what we learn about what is control component, what is uncontrolled component. We'll also learn about state versus DOM update. Then we will learn about when to use, what at what point of time. So a control component is a React component that are managed by React.js and can be updated using component state. Okay, a control component is managed by React.js and can be updated through component state. But uncontrolled components are managed by the DOM and can be accessed through refs. So this is the difference between the control components and uncontrolled components. Now, if you are lost a bit trying to understand like what exactly it is, I want you to go back to the definition of declarative versus imperative. So in case of React being declarative, we tell React what to do, but we don't tell React how to do it, right? We just update a bunch of states and then we use those state variable into JSX, and then we see like how the updates are getting attached to our DOM and the final HTML that we get to see, right? But in terms of uncontrolled components, where you do the DOM manipulation directly, right? You update the DOM manipulation directly. You need to have a reference of those DOM into your React component so that you can play with it. In those cases, for those components, we call them uncontrolled component. Now let us see some example of control component and uncontrolled component through code so that we kind of understand and appreciate them. Now let us first go over the example of a control component. The code that you are seeing on the screen is an example of a control component where the component is a pretty simple one. It has an input element, a type text, and there is an onChange handler. It means that whenever someone typing anything on that input type text box, this handle change gets called. On the handle change, we are getting the value that user will be typing in the text box, and the same value we are populating into this state variable, value state variable, by calling the set value updater function, right? This is very, very simple, right? Now this particular, in this example, the input element, this particular input element is a control component, okay? A controlled component because, or you can say it's a controlled element because its value is managed by the state variable called value, right? Its value is managed by, the value is managed by the state variable called value. When the user types in the input, the handle change function gets called and it updates the value state with the new value. So this is why it is a controlled component, right? It is not uncontrolled component. In case of uncontrolled component, we'll see that it is the value is not actually getting managed through the state variable, but rather with the DOM manipulation directly through something called refs or the reference. So now let's learn what is ref. So what are refs in React.js? We told that for uncontrolled component, basically the component is managed by, the value is managed by refs. What is refs? Now when you talk about refs, we mean that it is something like a reference, okay? And to get reference on any of the element in the React world, we have a hook called useRef. Okay, so useRef is a very simple built-in hook that's objective is to help us to persist the values between renders. But useRef never ever re-render the component by any chance. In case of useState, what happens whenever you are setting a value using the setState method, the components re-render. But in case of useRef, it never re-renders, but it helps to persist the value between two renders. Now useRef optionally takes a parameter as an initial value. It's an optional. You may or may not want to pass, but what it returns something called a ref, a reference. So a reference is nothing but, in the plain JavaScript world, if we call, it's like an object. It's a simple object which is having a special property called current, current, current. So again, to iterate everything, useRef is a built-in hook. The purpose of useRef is to persist the values between renders, but useRef never ever cause a re-rendering of a component. useRef may have an optional argument. You may omit it or may have an optional argument as the initial value. And useRef always refer a reference, an object, to the element, and the reference object has a very special property value called current. So if we want to retrieve the value of that particular element which is being referred using useRef, we will be using the .current property to get the current value of that. Okay, so this is what the useRef. Now if we want to create an uncontrolled component, in the opposite of the control component that we have seen, where we are managing the value through states, for uncontrolled component we have to manage the value through refs, and for that we have to use the useRef hook. Now let us see one example where we will be creating an uncontrolled component using useRef. Let's see this example. In this example, the input element is an uncontrolled element, and an uncontrolled component is what we are creating over here, because if you see, there is nothing called a state over here. We don't have the useState hook. We have not declared any state, nothing. Instead of that, what we are trying to do now, we are trying to deal the value of this input element using reference. Okay, let's understand that. So I told that for reference in React.js, we need something called useRef. So we have a useRef hook we have imported from React, and we got this ref instance. This is the reference instance. Now each of the references returned by useRef should have a special property called current, current. The current will actually signify the component which we are trying to refer. Okay, the element, the component that we are trying to refer. So if I take this init ref and if I put this as a ref attribute, ref, this ref attribute to any of the HTML element, it means this input ref or this reference will refer to that particular element only. So in this case, when I am saying input type equals to text, ref equals to input ref, that means wherever I am taking input ref actually have a reference to this particular input element. Okay. Now if I have the input ref dot current, it is going to give me the input element. Okay. If I do the input ref dot current dot value, it is going to give me the value of this particular input type text box, whatever the value in that particular text box. So through reference, if I have to get a value of our input type text box, what I have to do, I have to first create a reference instance using useRef. I have to assign that as a ref attribute for this element, and then I can do a input ref dot current dot value to get the current value, the value that is there in the input box I can actually get. Right now in this particular component, I have a button. On click on the button, I'm clicking and then I'm having this handle click function call. On the handle click function call, I am just logging whatever the value in the input type text box. And how am I getting this value? I'm getting the value through the ref. So this component is not a control component because I am not managing the value through state. I am managing the value through reference, so it is an uncontrolled component. Now there might be a question that why are we using the uncontrolled component at all? Because we are supposed to use always through state. Yes, that's right. So wherever possible, please create control component. If you may want to choose for uncontrolled component only a few circumstances. For example, you have to set a focus on this input type text box by clicking on some button. So on the handle click, you might want to kind of set the focus. The easiest way of doing that will be input ref dot current dot focus, right? It means that you are actually getting the focus attribute to true, and it is actually setting these things up. So it means something when you have to really do directly at the DOM level, you think that through state doing that will be a little bit difficult, little bit tricky, but you have to do things in the DOM level directly. Only on those cases, please take advantage of useRef, take advantage of ref, and make the component as uncontrolled component. Otherwise, always try to do control component. I hope the answer of this question is now very clear. Our next interview question. The next question is, how will you create a self-clicking button with React.js? Interesting. What does self-clicking means? It means when the button is getting clicked, it is supposed to do something. It is supposed to perform some action. So self-clicking means that action happens automatically. The same actions happen automatically as if that somebody is clicking that button, right? So the purpose of this question is like to see few things. One is like how to use a button click, how to handle a button click, how to use some of the JavaScript web APIs like set timeout or set interval, so that in some interval we can actually click this one. How to do self-clicking means maybe something we have to do at the DOM level. Maybe we have to take care of the reference that we have just learned in the previous question. Let's see what exactly we need to do. So what are the essential React.js concept behind the code that we'll be learning, right? So let's get into the code and start seeing how can you create a self-clicking button. And while doing that, we'll learn each of the pieces of the code. So a self-clicking button is something like this. It's having like, auto click you can see over here. Let me just put on the console and then refresh this guy once. Okay, clean this up. So you see like, is getting probably auto click means something is getting clicked 4 times, 5 times. Every second it is getting clicked. If I click it by myself, you see that there's the same thing happening. The number of increasing, much faster. If I just leave it, every second the number will increase. So it is doing the same thing that, should happen when I click on this particular button. Now how this self-clicking button happen? Now to create a self-clicking button with React.js, you can use useRef hook to create a reference to the button element. We have seen in the previous while answering one of the previous question is like using useRef, you can actually get a reference of any of this input element, and then you can do whatever you want to do with that because we have the direct access to DOM then. So in this case, we can actually do that, and then we can use useEffect hook to programmatically trigger a click event on the button. Okay, so let us see the code, and then we'll be able to understand like what exactly happening over here. So let's go to index.js. Let me just put this guy over here, put this guy over here. Let's go to app.js and try to understand the code line by line. Okay, so first thing, I'll go to the JSX part so that I can explain it well. So I have a div over here, div having some kind of basic style, forget about that for a moment. And then I have a button, which is nothing but this auto click button. And then I have a paragraph. The paragraph shows basically, at a particular point of time, the current time, how many times this counter has been clicked. Okay, so this is what it shows. This is what it comes here. Now there is no other code whatsoever. We don't see any kind of handle click, any kind of things all together that is happening at all. Then how these things are happening, how things are kind of taking in place. Now one thing that you can understand over here, like this button is having a reference. If you see this ref equals to input element. You can name it anything. You can name it button element or auto click button element, whatever you want. I named it as input element. So that means this particular input element will have a reference to this button. So it means that using this reference, I will be able to access anything and everything about this button. So what am I doing right now? Now, first thing I'll do is like, I'll go to my component, and here this input element, this reference is coming from useRef. If you remember, useRef is a standard React hook, which actually may take an optional argument. If nothing, I'm passing null, and it's giving me a reference. Now to show this counter, this particular number, I have a state variable called counter, which I'll be updating every second through the click of this particular button. Okay. Now what I'm doing over here in the useEffect is what? It's basically another standard hook for managing the side effect of your component. So our side effect of the component is with nothing but clicking on this button. So taking the same input element dot current will give me the current button. Okay, I am adding a event listener. What listener I am adding? A click event listener. And on the click event listener, what I am doing? I am attaching a handler. So it is same as whenever I am clicking on this event, this particular function should be called. Correct? So what is this function click handler? Nothing but increasing the counter by 1, which was initiated with 0. So every time I am click on this one, it is going to increment it by 1. This is the code that we have written. So you are seeing it is incrementing by 1. But we want an auto click. We want a self click button. That means we don't want somebody to click it to increment this number. That's the reason now I am actually creating an interval using a set interval JavaScript web API. So what exactly set interval does? Whatever the time you specify within that, but every occurrence of that time, whatever code you specify using this function, that code will execute. So it means after every 2 seconds, this particular function will execute. So after 2 seconds, if this function gets executed, in this function, I'm again calling this click function, like click method on the button. Input element dot current will give me the button because input element refer to the button with ref. So input element dot current will give me the button. Using the same button, I have previously added a click handler. Now if I am calling the click method directly, it means what will happen? The click handler will be called again, and again the counter will increase. So that is the reason in every 2 seconds, this is kind of getting increase. That is what happens. 50, then it will go to 52, then it will go to 54. So every 2 seconds it is happening. And the last thing over here, while answering one of the questions about lifecycle method, we spoke about like any kind of cleaning up that you can do. If you want to do any kind of cleanup, you have to return a function from your useEffect. This is what we are returning, a function, and anything we write inside this return function, that will be called when this particular component will be unmounted. Unmounted means detached from the DOM. So in this component unmounted, we don't want this interval to go on, because it's a JavaScript web API, it will keep going on. We want to kill it. For this killing purpose, now we're doing a clear interval method. Once we call this clear interval, the interval also will be stopped when this particular component gets unmounted. So I hope it answered the questions. A quick recap of whatever the things that we have done. We have created a button with a reference using the useref. So it means on this one, this dot input element dot current will always give me the button. Using that input element dot current, I am attaching a click handler, and that means this function will be called whenever somebody click on the button. In the click of that button, I am just resetting the counter and increasing it by 1. And then what we are doing, we are having a set interval of every 2 seconds. Every 2 seconds, we are programmatically calling this click method so that this click handler can be invoked. And so this is what is happening. Now, this is an interview question, a tricky questions, but that's how you should be answering. However, it's worth noting that creating a auto clicking or self clicking button may not be a best approach on most of the use cases. Generally, it is advisable that you trigger the event based on the user interaction rather than programmatic interactions. Like creating a self-clicking button may also make UI less intuitive, and harder to understand like what exactly happening, right? So our goal was to answer an interview questions, and we have done that. But in a real life, you may not use a code like this. I hope it is now understood. All right, so the next question and the last question of our first part of the React interview question series is about props drilling. Is props drilling a good approach, and what are the alternatives and when to use them? That's the question. That's a very frequently asked interview questions. So let us first understand what is props drilling, and then we'll see like what it means props drilling for a larger app. And then there are a couple of ways where you can find an alternative of, what is props drilling, right? So let's get into that. So first, we'll take you through something called state and props so that we understand the concepts very clearly. When you create a component and you have to deal with data, the private data of the component is called state. Okay? So state is a private to a component. Now, if two components has to talk to each other, they have to exchange data among themselves. Now, to do that, they pass something called props from one component to another component. The diagram that you see right now is actually talk about that. The blue dots are nothing but the state, where the red dots are nothing but the props. So this component having state. Now this component want to talk to this component, it passes a props. The props come over here, and we can do with the props something in this component. And again, this component may have its own state. The same props it may pass down to another component, and the props can actually really keep going down the component hierarchy. This particular phenomena of passing the props through the component in the hierarchy is called props drilling. Okay, so props drilling is nothing but a mechanism through which the props pass from one component to another component in the hierarchy. That's called props drilling. Is props drilling a good approach? Props drilling is not a bad approach as long as you are able to manage it well. So it means if the hierarchy is simple like that, there is a component, then there is a child component, there is a grandchild component, and you are just passing the props across, I don't think it is a very big deal. It is okay. But think about a case where you have too many components in the hierarchy. There are too many things in the down. Also, there are components which are like a bit disjoint, something like this. Now, this component has nothing to do this one. It has this kind of one child component. Now, there might be some kind of join from this to this, but this has nothing to do with this one. Now, in this kind of circumstances, passing the props using the hierarchy, it's little bit tedious. Like somewhere you have to probably update things from your child to parent, somewhere you have to communicate from the parent to child. While doing all these things, passing props drilling, passing the props and doing the props drilling might be a bit hectic when the application grows, when the application goes larger. So in that situation, there are few alternatives that you might want to consider. The two alternatives are very much important. One is something called a context API, and another is something called render props. Now both context API and render props we will take as a separate questions for discussions, because those require deep dive into understanding what each of this and how they are useful in for React developers. But at a high level, for this question's sake, context API is an API provided by React for sharing data among components. So it is something like a very static data, something that you want to store somewhere, and then you want to reuse that, utilize that across components without passing the data as props. That's the time you will be using something called context API. We'll get into greater details of context API in the future questions when you get to questions related to context API. But you can think about it, when you don't want to pass the props through props drilling, you have something called context API through which you can actually store some data through API, and you can retrieve it from another component at any point of time. The second thing that we have something called render props, which is a pattern, a React pattern, just like how higher order components is another pattern. So this render props, higher order components will touch base again in the future questions, but to give a glimpse, the render props is for reusability, where you can actually return a props as a function, and then you can use it as it is in another component without that component worrying about what you are exactly returning to. Basically, you can return the complete JSX, as a function, and then execute into a receiving component, so that you don't have to really pass across a lot of props between the parent and child. Don't worry if you don't get it, too much about render props and the context API right now, because we are going to discuss that in greater details in the upcoming questions. So to answer to this question, the props drilling is a mechanism to pass the props from one component to another component in the hierarchy. It is not bad it is manageable. There are not many components in the hierarchy, but when the hierarchy grows and you have to share the information across the components with hierarchy, or somewhere the hierarchy little bit is breaking, those cases props drilling may not be a very straightforward approach to use. On those cases, you have to make use of other approaches like context API to share the information, or render props, for reusability. So things like that we'll be talking about as well in our future questions. I hope this is clear.